Everybody, we're getting ready to do section 18 of SAT Math Level 2 preparation. And for 18, it's a section on matrices. You got 12 points to go onto your notebook guide, and 20 points will go on to your classwork sheet. This will be about addition and subtraction of, scalar multiplication of, matrix multiplication of, determinants and systems of equations, all pertaining to matrices, name, date, period, students, due date for onliners, homeschoolers. And we start out here, a matrix. A matrix is a rectangular array of numbers. The size of a matrix is R by C, where R is the number of rows and C is the number of columns. The numbers in a matrix are called entries, and the entry in the ith row in the jth column is called Xij. Two matrices are equal if they are the same size and their corresponding entries are equal. If R equals 1, the matrix is called a row matrix. If C equals 1, the matrix is called a column matrix. If R equals C, the matrix is called a square matrix. The numbers from the upper left corner to the bottom right corner of a square matrix form the main diagonal. So let's start in here with A. Evaluate x and y if we have this matrix here, 5, negative 3, x and 4 equals y minus 3, negative 3, 2x plus 2, and then 4 here. So we need to evaluate the value of x and y in this situation here. So how will we do that? These two matrices are equal if y minus 3 equals 5. So y minus 3 has to equal 5. This is the corresponding entry here for 5. And then x has to equal 2x plus 2. So x has to equal 2x plus 2. Therefore, in this situation, when you solve for y, it equals 8. When you solve for x, it equals negative 2. Now for this one here, for B, simplify. So we have 3 times this matrix minus 2 times this matrix here. And when we do that, we get this situation here now. 3 times each one of these entries gives us negative 6, 9, 3, 15, negative 12, and 9. And then minus, and then we multiply 2 times each one of these entries. We get 6, negative 2, 4, 2, negative 8, and 12. And then again, when we further combine these two matrices, we end up with negative 12, 11, negative 1, 13, and then negative 4 and negative 3. And then for C here, we have a C part of this coming up. C, solve the matrix equation. 2x plus this matrix here equals this here, so we need to find x to transform from this to this, okay? Is what we need to do. So 2x equals 5 minus 8, negative 4, 1, 3, 10, negative 5, 8, and 0. Then we're going to subtract. So what we're going to do, we're going to move this over here. And this matrix now will be the negative of what we have here in the inside the original matrix here, and all our signs are going to change now. So this will be positive 3 and 5 will be 8. This will be negative 2 and negative 8 will be negative 10. Negative 6 and negative 4 will be negative 10. And then negative 5 and 1 would be negative 4. Positive 1 and 3 would be 4. Negative 0 and 10 would be 10. And then negative 3 and negative 5 would be negative 8. Negative 6, the negative of negative 6 would be 6 and 8 would be 14. And then positive 2 and 0 will be positive 2. So now we get 2x equal this matrix here. Now when we divide these by 2, every entry by 2, we get this matrix here. So that would be how you would solve that. Matrix multiplication takes place when two matrices, A and B, are multiplied to form a new matrix, AB. Matrix multiplication is possible only under certain conditions. Suppose A is R1 by C1 and B is R2 by C2. If C1 equals R2, then AB is defined and has size R1 by C2. The entry Xij of B is the ith row of A, times the jth row, the jth column of B. If A and B are square matrices, BA is also defined but not generally equal to AB. So these are some ideas here that you should have brought into your prep for level 2. If not, I have background lessons that you can brush up on your matrix multiplication that I strongly suggest you contact me for that packet for matrices. Okay, so we're going to do part D now of this section. Evaluate AB, which is our A here is this 3 by 2 matrix, and then we have a 2 by 2 matrix here. A is a 3 by 2, B is a 2 by 2, meaning 3 rows by 2 columns, 2 rows by 2 columns. So we're going to multiply this times this is what we're going to do. So the product matrix is a 3 by 2. They're calling this the product matrix or the multiplier matrix with entries of xii. So we're going to multiply row 1 times column 1. And then row 1 times column 2 is what we'll do that way. And we calculate it as follows here. So x11 would be 3 times 1. And then negative 1 times 5 here. So this row by this column, this will give us negative 2. The product of row 1 of A and column 1 of B would be negative 2. And then for 1, 2 here, so we go row 1 by column 2 now. So we go 3 times negative 2 plus negative 1 times negative 3. That gives us a negative 3 here. Negative 6 plus a positive 3 is negative 3. So the product of row 1 of A and column 2 of B would be negative 3. And then we go x21. So now we're going to go row 2 times column 1. So we go 3 times 1 plus 5 times 5. This comes out to be 28. So the product of row 2 of A and column 1 of B is 28. 3 times 1 and then 5 times 5. And then we're going to go over here. 3 times negative 2 and then 5 times negative 3. And that's negative 21. x22. Got. And then we go into x31. So be negative 2 times 1 plus 1 times 5 equals 3. So the product of row 3 of A and column 1 of B would be positive 3. And then 3, 2 here would be negative 2 times negative 2 plus 1 times negative 3 would equal 1. So the product of row 3 of A and column 2 of B would be positive 1. So therefore, AB, A times B will equal negative 2, negative 3, 28, negative 21, and then 3 times 1. Note that BA is not defined. So if we go back the other way here, you would run out of ways to multiply there. you go row times column. And you have 2 rows here. So you go 1. How would that be? You'd have 1 times 3 plus negative 2 times 3, and then we'd still have this down here, which wouldn't be multiplied by anything. So you cannot switch positions here. It's not commutative, is what they're trying to say. Okay, so matrix calculations can be done on a graphing calculator. Hooray! To define a matrix, enter the second matrix, highlight and enter edit, enter the number of rows followed by the number of columns, and finally enter the entries. The figures below show the result of these steps for matrices. So A and B of example D, which we did, this is what it would look like. Here's matrix A on your graphing calculator screen, and then here's matrix B here. That's what it would look like. So 1, 1, this is 1, 1 here. To find a product, enter second matrix names A, which returns A to the home screen. Also enter second matrix names B, which returns B to the home screen. Hit enter again to get the product. And then here's your product here. -2, -3, 28, -21, 3, and 1. Square matrices of the same size can always be multiplied. The product of square n by n matrices is a square n by n matrix. A identity matrix, IN, is a square matrix consisting of 1s down the main diagonal and 0s elsewhere. The product of an n by n square matrices A and an identity matrix is A. It always returns back to A. In other words, identity n is a multiplicative identity for an n by n square matrix. So of course we got to try one now. So the identity matrix, here's our diagonal here, I2. If A equals this, 2, -3, 5, and 1, evaluate A, I2 equals I2A, which equals A. Or is this commutative? So A, IN, here's A, and then here's our identity matrix here. So we go 2 times 1. 2 times 1 plus -3 times 0 give us 2. And then 2 times 0 and -3 times 1 give us -3 here. And then down here we go 5 times 1 and plus 1 times 0 will give us 5. And then 5 times 0, then 1 times 1 will give us 1. So we end up right back to where we were. And then identity matrix times A, now we flip this, we commutate this, commutate it, I guess is one way of putting it. And we have 1 times 2 plus 0 times 5 will give us 2. 1 times -3, and then 0 times 1 will give us -3. And then 0 times 2 will give us 0. 1 times 5 will give us 5. And then 0 times -3, and then 1 times 1 will give us 1. So it just shows that it is commutative. The identity matrix and the another matrix that you gained your identity from. In general, matrix multiplication is not commutative in general. So let's try one. If A equals -2, 5, 1, and 3, and B equals 6, 0, 3, and -5, evaluate AB and BA. So AB here, now when we do this, -2 times 6 is -12. 5 times 3 would be 15. -12 is 3. And then -2 is 0. 5 times -5 is -25. That goes there. And then 1 times 6 is 6, and then 3 times 3 is 9. That'll give us 15. And then 1 times 0 is 0. 3 times -5 is -15. So AB gives us this here. While our BA now, we go 6. 6 times -2 is -12, and 0 will be -12. Then 6 times 5 is 30, and then 0 times 3 is 0. We get 30. And then 3 times -2 is -6. -5 and 1 is -11. And then 3 times 5 is 15. And then -5 and 3 is -15. And that gives us a 0. So this is BA. And then this is AB. So you see how it's not commutative. Multiplication would not be commutative. The determinant of a n by n square matrix is a number. The determinant of the 2 by 2 matrix A, B, C, D is denoted by AC, BD, which equals A times D minus B times C. So we get this diagonal multiplication thing going on. Determinants of larger square matrices can be evaluated by keying second matrix math determinant on your graphing calculator. And again, if you need background for finding the determinants of larger matrices, I have packets for that. Contact me at my email. So we're going to get into one. Write expression of this determinant here, 2, -1, 3, and x. So by definition, we have 2x and 3 times -1. So we get 2x minus a -3 here, which becomes 2x plus 3. And then solve for x in this situation here. So we have this matrix here equals this matrix here. So the determinant on the left side is x squared minus 8x. Use the calculator to evaluate the determinant on the right as 9. So this, if you knew how to do this by hand, then you could do it on hand, but they recommend you using a calculator, which is great, but you can also do it by hand. This yields the quadratic equation x squared minus 8x minus 9 equals 0. This can be solved by factoring to get x equals 9 or x equals -1 for this quadratic here. And this is extraneous, so it'd have to be x equals 9. Okay, so a square matrix is called singular if its determinant is 0, and non-singular if its determinant is not 0. Only non-singular matrices have inverses. So the inverse of a non-singular square matrix, A, is defined as a square matrix, the inverse of A, of the same size such that A times its inverse will equal the inverse times A, which will equal an identity matrix. The inverse of a non-singular square n by n matrix A has a multiplicative inverse of the inverse of A, where the inverse of A times A will equal the A times the inverse of A, which will equal an identity. The inverse of A can be found on the graphing calculator by entering matrix names and then A, which all return A to the home screen, followed by the inverse x, and enter. So there's different ways you can revolve back onto each other by using your calculator. So if A equals this, 7, -3, 1, and 4, and B equals 5 over 2 here, this column matrix, solve for x when AX equals B. So we're going to solve for x when AX equals B. We're trying to get something that you multiply this by x and we'll get this here. So matrix multiply both sides on the left by the inverse of A. Inverse of A times AX will equal the inverse A times B. this yields inverse of x equals inverse of a times b will equal this here. So when you do that on your calculator, this is what you'll come out with, 26 over 31, and then 9 over 31 will equal b. So when you multiply this times this, you'll get that, is what it amounts to. So the inverse of a times b will equal this. The fractional form of the answer can be obtained by keying math enter. So you'll probably get decimals, and then you'll go from your decimals to this here. I mean, either way, I mean, decimals will be fine. But the test itself will probably they'll probably offer answers in fraction form. An important application of matrices is writing and solving systems of equations in matrix form. Okay, so now we're going to move into a system of equations here, solve the system. And we have an x, y, and a z variable selection here. And here are constants over here. So how are we going to do this? The matrix form of this system is ax equals b, where a equals, here's our a, here's our x equals x, y, and z, and then our b would actually be our constants out here. Here's our coefficients for this part of the system. Then we have x as our variables, then b is our constants. So A is the coefficient matrix here, X is the variables matrix, which is a column matrix, and B is the constant matrix, which is a column matrix there. So what do we do with something like that? This system can be represented by the single matrix, a 3x4 matrix. So here's our 3x4 here. Here's our coefficients, and then here are our constants. In general, if there were n equations and n variables, then matrix A would have n rows and n plus 1 columns. You can use the calculator to transform this matrix to reduced row echelon form. Remember that, and again, if you're rusty on your matrix operations, I have packets for this. Contact me for those. This transformation involves multiplying a row by a constant, or multiplying a row by a constant and adding the result to another row and replacing the second row with a sum. This is the same procedure used to solve a system of 2 equations and 2 variables. These operations are done with the intent of transforming the first 3 columns into a 3x3 identity matrix. As this is done, the 4th column transforms into the solution. So you got to turn the 3x3 part of that matrix into an identity matrix, and then what you're left in the 4th column would be your solutions. So we go from this to this. So we have our diagonals here. Here are our solutions here. So x equals -2, y equals 7, and then 3 would equal z. So that would be the way. Here is our identity matrix here. We turn this into this by row and column manipulations. And so I have those packets. If you already are up on this, then you're fine. If not, contact me for those. And that is your Section 18 SAT Math Level 2 preparation, animated PowerPoint math video at AOL.com for course materials or questions. Thank you very much.